So this is the second part. Any questions from the side? No. So this one is about wave refraction, diffraction, and reflection. Very similar wording. So we should find out what is the difference. And the wave is another subject of part, and sediment is sand is moving. So wave is a kind of energy transportation and caused by wind. So wind is the most important for the wind and current. And reflection is all three are change of something, or wave, or material wave, or water wave, or optical wave. There are so many electromagnetic wave, many different kind of waves, but here we're talking about water waves. So change in direction by bounce surfing or through the different medium from air to water. There's light is reflecting, but also water waves are reflecting through different medium or different temperature. And diffraction is because of the opening or rounding of barrier. See that these are refraction, so because of the bending of wave crest, because of the water depth is different. So the protruding lens has a focus of wave. The waves change their direction toward this protruding one, so that this one can be smoothed out by a long time. But if there is a rock in the protruded one, then the rocks are remaining. So that can give you a special view. Diffraction, because of the opening, there is an opening between rocks. The water is change the direction, so it looks like this one. And energy, here you see this diffraction phenomena. Laterally, so breakwater or small island gives you at the end of this piers, the water has a diffraction, so the change of direction there. Okay, and then reflection usually goes with the light, but here the water wave is coming toward the, oh, there's a video. You can see the video.
Sun just set, and there's an incredible amount of physics to be learned looking at these waves and going through shallow water. What I'm looking at is I'm looking at waves traveling in towards the beach, and then waves reflecting out through the waves that are traveling in, meaning waves coming in, bouncing off the beach, and reflecting back out. Now, while they bounce back out, you can see the incoming wave interacting.
All right, that's enough. And then wave breaking. So at shallow water, the wave is made of circulating water particles. Because of the shallow water, the circulation hit the earth at the bottom. The wave speed decreased because of the friction of the sand, so that the water depth increase. The wave is forming higher, and then finally it goes break. That is the three phases: deep water wave, transitional water waves, and then shallow water waves, and then break. More can it there. And the wave run up is a maximum vertical extent of wave uprush. The wave is coming toward the sand, so we can see this kind of phenomena when we reach a beach, sand beach. The beaches and coastal production structures need to think about this phenomena. So R can be the size, and sediment transport, solid material such as small sand, fine sand, or big gravel can be transported depending on their size and weight, and also water speed, and settle down into the bottom of the liquid. So it depending on the grain size. Okay? And there is a suspension that's coming together with the water, and solution can be more smaller size, and big gravels or stones, and smaller ones are moving. So the equation for the how the stone is moving is because of the water drag forces and also friction. And lift is coming from buoyancy because of the volume. The displaced water gives you a lift. So the equation is a little bit complicated. So they can calculate when, how the stone or object can move. Here is one video. Let's see.
What's it like to learn math on Brilliant.org? Brilliant gets you hands-on to help you learn by doing. Learn topics from So this video is coming from Aachen University of Germany, and also Department of Civil Engineering. So because that one is about to study on river or stream. Okay, oh, that's the end of slide set already. So it's faster, okay. And we can have a 5-minute break until 9:15, right? Otherwise, you don't have any questions.